everyone, I'm doing more hydrophone work, basically just software work at the moment, and I have three goals that I think I've hit maybe last night and tonight. The big one is to, well, obviously, be recording continuously from the hydrophone. The other one is I want to generate spectrograms so it's easy to review the audio. And then lastly, I want this to be available through a web server so that way you can test while it's in the field. So this is the same setup. We have the hydrophone running into the USB converter. USB runs into the Raspberry Pi. Raspberry Pi is plugged into a battery. So nothing new there. And let's just take a look how we're going to get the software rolling. I have a bit of my own Raspberry Pi environment for these projects, and I'm trying to standardize a little bit. So there's some systemd services I've written that I just hope I'm going to use in every project. But so let's just start by looking at the capture script. This is done in Bash. I'm not like a Bash wizard. I don't know nothing either, but it's not like my go-to for much. But yeah, basically I have like a few key functions I need to run. In this case, it was just a record function. And then honestly just plug into ChatGPT and say, okay, I want to run this record function, continuously, put it in a while loop for me, and do the file naming. So that's actually pretty efficient. I think maybe long term for flow control, maybe this should just be wrapped in a Node JS script or a Python script, but we're up and running. So let's actually just run it. Too lazy to SSH mod. And you can see we're going to capture for 60 seconds. I think in real life we'd have maybe 10 minutes to an hour depending on kind of how this optimizes. And then once this is, so we can see that we're writing a WAV file, but we also have this function to generate spectrograms. And this actually is like an FFmpeg one-liner in terms of generating it. It's down here. You can pick the resolution, and this will make a PNG based off of your audio data, which is fantastic. And then the rest of this, again, generated by ChatGPT. So we have our recordings folder, spectrums folder. This shouldn't be here anymore. But yeah, basically it's just going to check and see if the file's currently being written to, which I think is good. So that way we don't analyze incomplete data. And then it's going to see if it's already generated a PNG for that file, so we don't double process. And then we just finally get to run our FFmpeg. And if there's, whoops, what did I do there? Where was I? Yeah, we're going to run this generate function. Not the capture function, the generate function. And you can see it's going to start processing these WAV files. Yeah, again, all FFmpeg. And we've already put a few in here. And what I should actually do now, and maybe I should have done it earlier, is I'm just going to tap on this hydrophone a few times. And we're going to see if we can visually review when that tap happened and find the corresponding file. So, I mean, obviously we know it's going to be this one. But again, if you have hours and hours of data, this is where the spectrogram, I think, is going to shine. Still processing the first file. But what I'm using is Python's HTTP server to host all of these files. Because when it's in the field, I want it to be accessible. I've never used it before. It seems like it's really simple. I don't want to get too into the muck on setting up firewalls and a bunch of security features. I know it's important. Whoops, you guys can see my password. But really just way outside the scope of this project. So this is just going to make the hydrophone folder available over this port, and we do have a login. Yeah, anyway, this will be something to clean up, but that's way after. We have so much field testing to do. But still, let's fire this up. And now we should be able to see our hydrophone folder. So if we actually had a way of getting our dynamically assigned IP from our cell server, we should be able to get to this. So in the recordings folder, you can see all of the audio recordings we've taken. I wanted this to be an MP3, and I had FFmpeg doing it along with the spectrogram generation, but it really just falls behind and can't keep up with the audio recording on the Raspberry Pi. So it's going to be uncompressed WAV files for the moment. Yeah. It would be nice also because then we could review, we could play, it would play right in the screen, I think, but. And then here we have the spectrums we've generated. So we haven't quite caught up with everything. And I think ideally what would be really cool, maybe later on in the project, would be to have like a media player that had this plot somehow. And so like you could, as you're scrubbing through, like wherever your position was on the media player would correspond with your position in the file. But that's like a pretty big software feature, and I think we're getting pretty close here. So let's see if we can find our taps here. Doesn't look like they're in here. There they are. That's pretty damning. At 17.5 seconds into the file, we can see my 4 or 5 taps here. So we can just check this file name, 172258. Go back to the recordings, download the recordings, and let's play it. Let's see what we get. Somewhere at like 17 seconds, we said. Nice. So anyway, I'm hoping this is just going to make it really easy to, like, if you're looking for dolphins and other cetaceans, right, you're going to look for those high register frequencies. If you're like looking for boat traffic and so forth, I think it's going to make it really easy to kind of identify and quickly classify training data, or without having to manually review everything. Yeah, obviously it'd be nice to have a few other tools, but I think this is like a great way to get going. Awesome. All right, guys. Yeah, I'm trying to build it up. Hopefully, I'll have it in the water this weekend. That'd be my goal. It's a pretty simple setup, and it should just be a matter of connecting it to the battery pack and getting everything housed and getting the hydrophone out through a gland in a secure way. So, I'll talk to you soon.